Hello, welcome. I'm Bill Wake. We're here working on an application I'm calling Swarmed. It's an old basic application that's a game from the early 1980s. And we've done a bit of work to restructure it and get it into a modern looking kind of Swift. It's still not acting as a modern Swift application as far as like model view controller or something like that. But I think we're going to pause on changing it further and focus on harvesting the basic support out of what we did so far. So the application looks something like this. You've got a ship, it moves horizontally, and then on every kind of tick, the row of stars at the bottom fills up and the whole screen of stars moves towards you, and you have to avoid the stars. Okay, not much to it. Okay, let's get over to the IDE. Okay, so I just ran the test. Everything's still running there. Let's just run the app once here. I'm saying extract basic support to a library. You know, there is something we should do first. We found a bug, fixed bug about moving in whole star, whole field. Okay, we'll see if we can show that here. So if I head left, a hard left, I can get as far over as the farthest left star or asterisk. I guess they're asteroids. Let's see if I can do the same here. My timing is off. Okay, what I'm noticing is right there's a star to the right of my V. I was pressed all the way over, so I can't get all the way over. So let's see what's up with that. So we're okay. So what we see, kind of like the key lines, generate asteroids. Let's get down there. Let's see. So here we're doing 23 times random, and random ranges from 0 to like 0.99999 whatevers, in which case 23 times it is 0 to 22 somethings. So 0 to 0.999 is 0, up to 22.9999 is the maximum value. Okay, so we're only putting out 22 stars, 23 stars in a row, right? Am I doing this right? If it was 1 times random, we would have 0 up to 1, and it would just be 0. So it's n minus 1, 22, so 0 to 22. Okay, our screen is 24 characters across. Let's see, we've got a picture somewhere here. Yeah, down here. It's 0. A 0 gets here, and a 20, let's see, 0 plus 0 plus 0. So this is 5, 10, 15, 20, 1, 2, 3. Okay, so we can't actually fill in the last column of stars. Okay, which is probably a flaw. Let's try that. We don't have a lot of, we don't have any tests up at this level, so we'll do it manually for now, and then I'll do a couple manual mutation tests, as it were. Okay, so let's run. And these old screens on this computer were 24 by 24 visible spots. There were more in memory locations that could have been mapped, but they weren't. Analog TVs didn't have much resolution, and the circuitry used even less of it. Okay, so what we're trying to see is we would like to see stars in the far right lane. I guess I should be trying to get over there. don't think I can make it. Nah, let me try it over again. Okay, get a little lead in. Okay, yeah, you can see we've got two columns. The far right one got filled with a star now. So I think that we would call a win. If it were messed up, it would, probably not show up somewhere or something like that. All right, so that's there. Now let's see this. Yeah, well, that we can see here. These magic numbers and stuff. Clearly, we have room for improvement on the refactoring, but basically, if you're greater than 0, then we let you go down by 1 to 0 and don't let you go further left. If you're less than 21, we let you turn into 21. But we just saw that if this is 21, 2, 3, should be allowed. So this, if it's less than 23, we should allow you to do that. So we saw we couldn't get to the right 2 columns. Add 2 should make it 2 columns. I'll just run it. So I would characterize the refactoring we've done so far as we spent a lot of time trying to get it into a structured program, ifs, whiles, loops, that kind of thing, rather than go to, if, go to, and stuff like that. All right, let's try and get over to the right. Yeah, I can see we're further over. We get the same path of stars, and there's the blank star on the far right that killed it. Okay. Notice also B-O-O-M exclamation point. It gets cut off. You could imagine making it so that it didn't, but this code does not do that. Okay. There's another one. All right. But anyway, we did a lot of work to get this into a structured program. Here's a while loop. We generate the pairs of values, then we run through them once. We've got some, well, we certainly did a bunch of renaming to get these variable names. They were like AN, LW, and so on. Okay. And we did a bit of work to extract methods, but we still got stuff that's peeking out through here that's just very dependent on things. And when you get in here, it's even more crazy. Well, ship base we'll look at in a second, but 66 is B-O-O-M exclamation point there. So that's where that's getting written out. We can see these screen start, screen end, characteristics of the screen. There's our 24. We should be using that stuff instead. Okay. But I'm not going to do more to this. I mean, there's room for improvement for sure. There's also this goofiness, and we took a stab at fixing that. I think what I'm understanding, and I did a little more reading, there were different models of this OSI computer, and some of them, to read the keyboard matrix, you set the values you wanted to find. Other ones, you cleared it. And so I think what this is doing, well, this one sounds like it's assuming, I guess it's saying column 16 should be blank. I think that's saying column 16 is hit. And if we'll go down to read keyboard, it turned on all the rows. So we just had to worry about which column. All right. So let me go back to the reference material. Okay. So I think it's saying if this is 0, then this key is actually activated. It could be BGT, LF. We could use any of these characters instead because it's set 255 on the row addresses. I don't know. Maybe the row addresses are positive logic and the columns are negative logic. It's just bizarre seeming. But okay, we didn't try that combination, but I think that may be what's going on because it turns on 255, but then it looks for not 16. Okay, so we didn't try that variation. I don't know. Maybe that's worth a go. We got a few minutes we can put into it. Okay, so let's see. So what's going on is sort of the simulation is kind of cooperative between different things, and I think for 0, this maybe should be not 16 and not 8, and this should be not 0. Okay, so that's saying we got positive logic here. Which row do you want to turn on? B or N, basically. And which this should be set the other way. So let's see if that makes sense with Swarm again. Okay, so we set 255 here. That to me says turn on all the rows. And then if column 16 is off, meaning it's hit, okay, and our neutral will be disagreeing, and if 8 is off. Okay, and there's a little ambiguity there if you hit both at once, I guess, but that's okay. All right, let's see how this looks. Oh, I should have pushed what I did before. I'm getting really sloppy on that. Okay, so what I'm hoping is the negative logic works. This goes left. And this goes backwards. Why? Well, that's what we hit before. If it's 16, go left. Let's check out our 16 again. 16, that sure seems like the right one. And 8 is N. B is left of the N on your keyboard, or if you at least US English one. All right, let's think it through. Apparently not my specialty. Okay, so I'm saying row 4 gets turned on, column 16 gets turned off. All right, so I guess we got 3 cases going on. Let's be a little systematic here. Okay, so fixed bug about moving in the whole field. I would say we did that. All right, and it had nothing to do with content view, so I'm just going to cheat and push without content view. Okay. Oops. Okay, so it's interesting to me we caught a bug that had been there for 40 years. Not heavily used in the last 39 and a half, I'm sure. But okay, so now the 3 cases. So less than, which is our thing on the left. Less than, it's supposed to simulate B. And it's got row 4 set, column 16 cleared. Oh, I got them backwards. No wonder. Okay, row 4, column 16 is supposed to be B. Let's check that here. Row 4, column 16 is B. Row 4, column 8 is N. Row 4, all columns set, none cleared, is empty. All right, let's try that. All right, that's working. Okay, so yeah, that logic's a little bizarre, but at least we're conforming to the logic that's there, and I've got the right key on the right button. Okay. Let's commit this. Well, I guess I could update my to-do. I think that makes sense to me. Hopefully it makes sense to you. All right. Commit that. Activate. All right. Now, I think that wraps up what I'm going to do with the game. This could all be a little. This method's not all written at the same level of abstraction, so it would be reasonable to do that. Okay. Now, what I want to do, there's really three levels going on here. So one level is the simulation of BASIC itself, and that is reflected in, well, go to. So the original way we did it, we had a loop while line not equals 0, go to, switch to line, and each go to statement in the original code. Let's go back there. Let's find a go to. Well, here's an implicit one. If low, then 200. Says if low, then go to 200. And so we made a switch statement with every one of these line numbers in it. And then the interpretation of this is check if low is not 0. If it's not 0, then go to 200. And that's the last thing in that switch statement. For line 20, the loop comes around again. It's got line number equal 200, and so it looks in there and says, oh, I got to set low equal to 0. All right, perfectly fine stuff. Okay. So the goto does that. Now there's a go sub. This can be a subroutine till it does a return, and there's some mechanism for that. Let's find go sub. Here's go sub. So calls is basically a call stack. Basic doesn't need one because it doesn't allow recursion, but it's certainly an easy way to get us going. And because these machines are running like ridiculously many times faster and ridiculously much more memory, we just don't have to worry about it. I think this was originally a 1 megahertz machine. And I have a fairly old Mac, but, not preferences. How about this Mac? I think this one's about 5 years old. Okay, 2016 model. All right, 2.6 gigahertz. Okay, so basically that's 1,000. A gigahertz is 1,000 times a megahertz, right? So we have 2,600 times the CPU bandwidth that we had back then. And instructions on 6502 are pretty darned primitive. If you were doing Well, it was an 8-bit processor. So if you were doing 32-bit arithmetic on doubles or, float or double, depending how you want to call it, um, it had to go into simulators and, simulate multi-byte arithmetic. And so it couldn't just do a floating point add in one tick or whatever. Um, so, and what do I have on here memory wise, right? 16 gig. Okay. That was a 4K processor or 4K RAM on that thing back in the low end model of this machine. So, 4K versus some number of 16 gigabytes, um, a K times a K is a million. So 1,000, another 1,000 gets you a gigahertz or giga, and times 4, I guess, because 16 versus 4. So literally 4 million times as much RAM as this. So yeah, I don't worry that I'm wasting a few bytes on this. So anyway, a call, you find the return address, you push that on the stack, and then you do a jump to the subroutine. That's pretty much a normal compiler way of doing it. Then return, well, if there's nothing on the stack, then you made some sort of mistake. You're doing a return without a go sub, and we're going to exit, or we pop this thing off the stack and set our next line there. All right. Let's see what else is going on. Well, okay. Then we have so that stuff is supporting BASIC. Then we have the for loops, which are kind of, they've got surprising amount of overhead, really. The old basics, the for loop would always execute at least once. So it would it would interpret until it hit a next statement, which could be anywhere because the way the code is written. Some newer basics started requiring, kind of reasonable loops. And I imagine they switched over to not going if the first one couldn't fit. But anyway, you also needed to do some management of nesting. So you can have nested for loops. And again, I'm creating a stack for that, a loop stack. And basically we have to deal with that. Then when you return and when you run them, well, you basically, if you just say next, then you just take the innermost active loop. But so we had to do some stack management around that, I guess, put it that way. All right, then we get to some things. This is random number generation. Maybe an example, but peek and poke are definitely an example. So in the old computers, the memory was mapped to the screen. So if you poked a byte at a certain location, well, anywhere between screen start and screen end, basically, it would theoretically be written to the screen. Now, our lines are smaller than the 30. It allowed 32 bytes, but it only shows 24. So you have to be a little pickier. But at any rate, basically that's what's going in is whatever goes in that screen address. If it's in that range of memory, it's going to get, potentially written to the screen. Then if you peek at this random address, they mapped that to an IO port basically. So that would write, this is that positive logic we just looked at. It would write to that address all the values that you poked in that byte. So whatever values you set, they're treated as bits, and bit 128 turns on this row and 64 turns on that one, and so on down to 0. And this is, you poke to this address to write to that and turn on certain rows, or turn on scanning for certain rows, and then later on you can peek. And if you peek this address, then it looks at the column and says which values are turned on, which columns are turned on, and they'll only turn on for the rows that you chose. Okay. Let's see. Print is probably more basic and dependent, except for this screen line distance. Okay. Well, what I want to do, okay, so that sort of is two levels. One level is basic, handling go to, go sub, for loop, to some extent print. Those are very common across basics. This stuff about where's the screen address and the pokes and on peaks and memory and keyboards and all that, that's very system dependent. So I'd like to separate those two levels. And then we have our actual application, the game we're working on, is a third level. And I don't want to, I don't necessarily want to include that. So I want to build something, I want to extract something that knows how to run these basic simulations, how to interpret this basic transliteration, I guess, and be independent of the application. So the next time I've got a, let's see, it's a printout of an old breakout game. I guess TM somebody, not these folks. All right. But, I have another game I'd like to try pulling in at some point. I'm not sure if it's the next thing we'll do, but, we'll see. But I'd like to be able to take all the basic interpreter stuff and just pull it in and have it work. And I'd like to do the same for the environment stuff. And maybe I don't need to separate those apart for now, but if I had, this was for Ohio Scientific, like Model 500 or something. If I had Commodore 64, it uses the same processor, but it's got a lot more memory. It's got a lot more graphic modes. It's got a lot of everything else. The system level dependencies would be different. It certainly doesn't use 57088 for its keyboard poke. It uses, I can't remember the number, but some other number. And it has a different number that if you just want to find out the result of doing all that peeking and poking, they have an assembly routine that runs and does the address on the keyboard matrix, translates that back into a character so you can see which keystroke it is. And I think you peak 197 to get that or something, but it's different anyway. But maybe I can just split out the two bottom levels together. Maybe that would be a bit of progress. And then if I started doing more with these, I can improve the framework as I go. All right. So I guess what I will do, I'm trying to think how we did this before. I created a library one other time. So let's do new project. Is it Swift package? Maybe it's this. All right, and this will go up. Oh no, I guess that's the right level. Let's call this BSim. Is that going to tell me what it is? Maybe not. How about basically? Okay, so I'm opening this new Swift library. I'm hoping I can figure out how to make this a packaged thing that I can pull into the other application. Okay. Okay, give me an example test. All right, now let's see what we can pull in. Let's try pulling in Swarm. We'll make a new source. Okay, and let's pull in his tests. I guess I'm going to fill it all in anyway, so that's okay. Basic support. import tests. I'm just pulling that from here. Okay. Well, let's see if we can run these, or if I got to do some. Cannot test on target. Oh. Let's choose a device. Well, what was I running over there? Just an iPhone 12. Let's start there. I don't know if there's other stuff I'm going to need pulled over. Ooh. We got to import combine. Am I not running in a recent iOS? Where is that set? iOS 14. Oh. Well, does that fix it? Okay, I'm going to search a little bit. Wait, that's Microsoft? No, that can't be right. Now, I may be misremembering, and maybe this is not the right thing, but okay, what do we got down here? You sleep. Did we include that somehow? No. Thread is not in scope. Okay, we do need this file. No, it's okay. Oh, okay. Cannot find thread. what did I call this thing? A Swift package. Is that kind of like we're seeing let package equal package? Yeah. Platforms. By default, it handles common resource types. You don't need to declare nib files. By default. Well, let's try that here. Do not let me copy. Onto a clean build. The sleep in SRAM may still have a problem. I don't know if that's covered by this. No such module swarmed. Oh, we called it basically. I wonder if it's just not there because we haven't got it compiling. Now I'm not happy to see errors, but I can understand use sleep SRAM. Thread I thought was right in the foundations. Well, let's try it. Again, maybe you have to be more explicit in this case. I don't know. Well, that seems promising. So many times foundation is not required. I would have thought thread would be one of those, but I don't know. I guess you sleep and those guys are. Oh, is it actually testing? Okay. Well, good. All right. That's probably a good place to take our first break here. So we've got the whole thing basically moved over. No UI. Just the two classes that really do the work and the tests. We didn't have any UI tests, so that one's irrelevant. All right, let's take 2 minutes for a break and come back and finish working on this library. Welcome back. All right, let's see. So I'm gonna minimize this old one for a minute here, just so we can focus on this. I really wish I could like change the color, background colors, but it's a global setting. So when I change it here, it changes it over there. So it's hard to keep track of which one you're in. But here we are. All right. So I think what I want to do, let's start pulling out anything that's actually got to do with Swarm. Let's rename this basic support. Okay. What are we looking like here? All right. So what we've done so far is we pulled everything from swarmed into basically. I didn't run my test just now. I probably messed up something. Don't these things create an object? Oh, the rename got it. Good. Okay, so that was a good check-in. All right, now this file is nothing. We'll delete that. Same for this one. Delete that. Build failed. I don't know who's here to want it. I guess this is basically test depends on basically. That seems okay. Well, let me do a clean again. Whoops. No, just some residual stuff. Okay. So what we've done is we removed unused. All right. What I want to do, well, I think what I really want to do is pull this run method. That's a good way to make this work generically. I really want to get the body of this run method out of here. So let me just comment it for now. See if our tests all pass. Okay, so that's just run. Okay, so those are not needed. Let's delete that. And since those aren't needed, none of this stuff is needed. These are the methods in our application. Okay, so this basically proves we don't need any of the swarmed stuff to do the testing of these things. Now, all right, I think, okay, so we removed swarm code from run method. Excuse me. All righty. And I want to reorganize this stuff. Okay, for next, that's standard between basics. This is mostly standard, but can vary. I'm going to pull this up. Well, so much for that theory. Delay and rand. Cut those here and paste them here. And this is I consider this environment because of this delay factor. So in the swarm code, I don't know if you remember, but there were things like for k equals 1 to 500 colon next k. All right. All it's doing is running an empty loop, but because there was no optimization there, it was just stepping through the loop 500 times, and that was slow enough to give it a, let's say, half-second pause. What do we set delay factor to? 4,000. So 500, a delay of 500 is pausing for about 500 times 4 is 2,000. So basically 2 seconds. Okay, so that depends on the machine, though. This number was decent for running hours. If I set this to 0, well, it may have started pumping through really fast, and then we couldn't keep up with the game. Okay, so that delay loop kind of thing gets done a fair bit. All right. I'm just going to draw a line here just to kind of keep my eye. I'm going to do a bunch of equals. Keep these things separated. Now, I think we may have to do them. And peek and poke are very machine dependent. Print cares about this, which is a machine dependent thing, but it's more or less independent. So my theory is there's 3 things. Basic environment, which is a function of the machine OS combination, and then the app. Okay, I'm thinking environment, my strategy is going to be environment becomes its own object. Basic knows the environment. And delegates some things to it. Okay. So well, I think this is more like print. It's a function of the last, I mean, it's a function of a value in that thing. So I'm going to keep it down here. If basic support can answer that question, then I think we're okay. All right. Whew. Okay, so let's make a class with these few methods in it. Okay. So I'm kind of doing an extract class sort of thing. We'll make a new class, environment.swift. Put this in. Okay. Okay, we need random seed, screen, and keyboard poke. Well, random seed definitely. Screen is a bit problematic. Screen start, screen end seem like they should belong over there. Well, all these seem. The memory, though, that's a puzzle. Keyboard poke. I'm not sure the right way to do this. Do we want to give the memory to the environment? I guess that's kind of the question. So we're saying the environment is what is observable. Keyboard simulated. All right, tests should not be affected yet. You would think I would have needed random seed. Did I pull that over? Okay, we'll have to get there. All right. I'm going to give this thing an environment. Okay. Now, I'd like to delegate through to it. Okay, so the random function... What is random seed used for? Maybe it's not used anymore. Okay, it's not used anymore. Ship. Well, we'll hold on to that one for a minute. Okay. So what I'm saying is random should be environment.random of value. All right, now do my tests cover rand? Rand 0 is constant. Okay, so these tests we're testing that extracted class indirectly. I'm okay with it, I guess. Oh, this is actually, I think that's actually wrong, the keyboard stuff, but okay, based on what we learned this morning. All our tests should pass, in particular our random tests should pass. Okay, so I'm going to try and delegate these top functions just right to the environment. Okay, peak returns an address. And I don't need the return on there if I'm not doing anything else. Okay. And poke should do the environment poke. Okay. Again, I'll run some tests. Oh, okay. Oh, print. What happened? Print. Okay, run main thread, remove first. I don't think. I'm going to revert. I'm trying to be careful. What did I change? Well, see what the other issues are. Print with text puts its last line. Oh, are we printing, are we changing the screen anymore? Let's see. Yeah, print affects the screen. Let's pull this over to environment. And we'll just delegate to it in support. Okay. Peek to ready keyboard with some key down. Swarm.poke. Swarm.keyboard simulated. Well, that's not really what we want to do. I would say this is really an environment test. And this is a very Snoopy test in a way. Okay, all this stuff is over on the environment side, so let's test it over there. And then we can get rid of some of these variables. Okay. So we put random peek, poke, and print are over on environment. So let's commit this. And I think I will split these tests. Environment tests. All right, the for loop we'll keep here. Go sub, return. Go sub, screen starts empty. Peek, print, peek, random. Okay, these all seem like environment tests. Okay. Now we're going to switch this to environment. And I'm just going to do it all systematically for a moment. Well, maybe I should rename it here first. All right, we should still have 21 tests, maybe 22. I might have duplicated that one. Okay. All right, let me put the tests left. All right, so screen starts out empty. Some peek, a print, a bunch of prints. Peek to read keyboard. I guess that's a bit different. But maybe we can... Well, maybe we should move these up. Print random. Okay. Now let's look at basic support. I think there's more stuff we can get rid of. Okay, we're going to make this a parameter at some point. Let's take delay factor and let's only use the environments one. Okay. Really? We didn't move that one over? Okay. I don't think anybody should be referencing these at this point. Okay. Basic support has no reference. Looks like one place. The screen. Okay, I guess we're saying the environment owns the screen. Alrighty. Environment. Okay, this should only be using environs version. Okay, environment has those 4 values. Basic support does not need them. These 2 should not be needed. Test should all pass. Okay, what else we got? Okay, that's our line number. Okay. Astro spaceship, those are not used. I don't think this should be used. I don't think this should be used. Nope. Error is the last value. There's an error message and you can print it out. The random seed should not be used. Okay, we're not going to need the comment. But I'm going to move print up there with the other ones that just delegate. Okay. All right. Let's run these tests. I think we're okay. All right. Let's take a break, 2 or 3 minutes. We'll come back and I don't know if I want to make separate objects for the for loop and so on. I think the real issue is what's the relationship between the run and what the user program looks like. So we'll tackle that when we get back. All right, see you in a couple. Welcome back. All right. What I want, it's sort of a little bit of frameworky in a way, right? We've got our users, they're outside, they're going to call basic.run, and then run's going to have to delegate back to the user because we don't know what your run is. But you're going to be doing a bunch of stuff that looks like peek and poke and print and go to and all that stuff. Now, are we going to make you change those to basic dot for loop and stuff like that? I think we are. Okay. So, all right. Well, one thing is this should be a parameter, not a fixed set. All right. So let's get that done first. Init, it's going to take an environment, type environment, and it's going to say self.env equals env. All right, and this is colon environment. Okay. Now all my tests have to change to environment. Is that what I want? Well, they create an environment. I think I want to do this. And I'm splitting this out because we do know somebody's going to have to look at the screen, so that has to be accessible to them, which means the support environment has to use it. Okay. Right. Basic support. Okay. Environment dependency to basic support. Right. Okay. Is this publishable? Well, I think we got to figure out. I think what you should do is give it a start of an int, your starting line number, and then we say while line not equals 0, we want to call something. Well, really, we want a switch statement here. This is the stuff you're going to pull out. Case 100, do something, default. Okay. We'd like the switch to be pulled up there. I'm just doing this to get something and see if I can extract. Well, what I really want is go to 0. And I want my switch. Oh my gosh. Well, I think this is this, isn't it? Nothing goes to nothing. It's a little arbitrary. Okay. I'm going to comment that at least. Whoops. Okay. So I think what we're saying is you call run, you give it the starting line number, and then you give it a method that basically consists of a switch statement based on line numbers, and that's all you do. Okay, let's see. Call stack. Let's do this like that. Now, Okay. Problem is I don't know where to go from here. I think, well, that should work. I'm not liking these case mixing things, so we'll deal with that at some point. Um, how do we package this guy up? Okay. I know I've done it before, but how to make and use a Swift package. That sounds promising. Okay, so I want... Okay, there's package, modify and customize. Make sure it's all marked public. That would be good. Okay, let's save ourselves one loop around on this. Okay, public class. Woof. Redundant for a public extension. Okay. I don't think you need any of that stuff directly, but I think this... He's not complaining about that one, is he? Okay. I don't think these need to... Oh, they do, I guess. Okay. I may have a bad balance between the memory and the screen versus who owns the screen, I guess. Yeah, more complicated than writing Swarm in 6502 assembly. Okay. Yeah, I probably know what I'm doing better there too, honestly. Although it's been a good long while since I did any assembly. Okay, so I've got everything public. It seems like I've add your package to Git tracking. Add a tag on GitHub. Oh. Add package dependency. I don't want to make it public really just yet. Well, let's see if we can add that. All right, so we're going to bring back the other window. Swarmed. And I want to add a dependency. File Swift packages. Okay, I guess I should tag this one over here. Is that what they're kind of hinting at? I don't know if I can tag. Okay, tag main. I'm not being very Standard, like, am I? All right. Swift add package dependency. Well, I did push that one up to GitHub. You would think there'd be, I guess I got to enter it here. Paste the Git link. And if you know this off the top of your head, please speak up. I'm not trying to run it at GitHub. Oh, I might have that around. Let's see. No. All right, let me try this. One sec. Okay. Not found still. Okay. Let's try that other method. Wow. Nothing. One more time, sorry. Okay. That did not work. Oh, get your raw dot. Did I get that command not found? I did. Not showing up here. Okay. Well, maybe I just got to push this thing up to GitHub. That's what I did for AlgoViz. All right. Okay. Okay, sorry to do this. Excuse me again. Okay. Basically, I just want to get this pushed up to GitHub at this point. I don't know. This is not really the case where I've already got something existing. I guess I can do this much. Well, let's do... I want the other one. Okay, so now... Nope. If I'm here... Go up. All right. All right. I don't think this is helping. Yeah, I am W Wake. I keep track of that much at least. Okay, I don't think I'm going to finish this in 2 minutes and get it integrated into the existing stuff. So I think we got one more session on this. It is probably going to be Friday afternoon. I think my schedule now is going to be Friday afternoon and Sunday afternoon for a while, 1 to 3 p.m. Eastern time. And we'll take a look at getting this Git thing done. I may just do the Git part on my own just to get that out of the way, but then integrating it in so that our swarmed application builds off the library instead of combining those two things in. Once we can build it that way, we'll peel out all that old support and hopefully have a good approach for next time. All right, thanks for joining me today, and I will catch you again in the future. Bye-bye.